We're going to learn a second type of improper integral today, and this is going to be where there's a vertical asymptote in the middle of the region or at one of the bounds. And last time we saw improper integrals occurred where infinity was in one of the bounds, and here infinity is going to be occurring kind of in the fact that we've got this vertical asymptote. The number infinity or the quantity infinity will not appear in the expression explicitly, but we have something infinite going on because we have this asymptote. So anytime something infinite is happening in our limits or in our integrals, we are going to have an improper integral. If we look at this first example, we see that x equals 2 is a vertical asymptote of this function. 2 is a place that makes the denominator 0, but not the numerator. So 2 is going to be our problem spot here. And so we're going to break this limit up into a limit as t approaches 2. I'm going to quantify that in just a second from 0 to t of 1 over x minus 2 dx. And we actually need this 2 to be either a left or a right-hand limit. So we're on the interval from 0 to 2. So we're approaching 2 from the left. We're plugging in numbers a little bit smaller than 2. I've had to record this video twice because I keep getting left and right-hand limits backwards. So if you get them backwards too, don't worry. So we're just to the left of 2. That's why this is a left-hand limit. So now we compute this integral like we normally would. You could do a u substitution with u being x minus 2. I'm not going to do all the work out there. When you do that, you're going to get an absolute value of x minus 2. We still have to plug in our 0 and our t. These are tedious rewriting the limits each time, but don't forget you do have to rewrite those limits. So we're going to have ln of t minus 2 minus ln absolute value of negative 2. This is really why those absolute values are important, because we can't take natural log of a negative number, but we can take the absolute value of that negative number and then take the natural log. So now I have to ask myself what's happening with this guy here. So t is approaching 2 from the left. So we're plugging numbers in a little bit smaller than 2. So maybe 1.9999. So 1.999 minus 2 is going to be a number that's a little negative, but close to 0. Absolute values will make it positive. So we're taking natural log of a number that's close to 0. If we look at the natural log graph, if we plug in numbers that are close to 0 into natural log, then our function is going to negative infinity. So this piece is going to approach negative infinity. Negative infinity minus the natural log of 2 is still going to be infinite. And so this integral diverges. Remember that we say these improper integrals diverge if we are not getting a number out. So so if we have a vertical asymptote either between our endpoints or at our endpoints, then this is an improper integral. And the way that we deal with it is exactly like we did here, breaking this apart into a limit, either a left or a right-hand limit. And let's go ahead and do one more here. So in this one, 0 is our vertical asymptote. Notice that these problems are deceptive. You could just start doing this one and not even notice that it is an improper integral. So do be very careful to make sure if your integrals are improper or not. So we're going to break this apart. A limit as t approaches 0. We'll decide if it's from the left or right in just a second. If I try and do it too quickly, I'll make a mistake. Let's rewrite this as x to the negative 1/2, so it will be easier to anti-differentiate. So we're on the interval from 0 to 1, approaching 0. We're on the right of 0, so this will be a right-hand limit. Now we anti-differentiate. So we're going to add 1 to this, so we're going to get x to the 1/2 times 1 over 1/2, which is 2. That's the same thing as 2 root x. We plug in our 1 and our t, so we plug our 1 in first. Square root of 1 is 1, so we have 2 minus 2 root t. And sorry, I should be writing my right-hand limits here. As t approaches 0, whether it's from the left or from the right, square root of t is going to be 0. So this whole thing will be 2. So that integral converges to 2.